Hi everybody, welcome to your last section in chapter 4 for roots and powers. So we're on 4.6, applying the exponent laws. So it's really important that you have done the work up to this point, because otherwise this whole section is going to look like a total disaster to you. So you need to make sure you understand 4.2, 4.3, 4.4, 4.5. And if one of those you're very confused or a little bit, come on and ask me, come on the Google Meet or email me a question. You need to understand that information to understand 4.6, okay? Because this is the accumulation of all that information. So the exponent laws, this is the really important stuff for today. We have seen a few of these in the past few slideshows. If not, you need to know these, okay? So these are the exponent laws that you need to remember. So there's the product of powers. So when A is just any number, okay? But it has to be the same. So let's say it's 2. So it's 2, 2, right? And then M and N are different numbers. So it's 2 to the power of 4 and 2 to the power of 3. We add 2 and 3, or 4 and 3, okay? So M and N are added, okay? So then that's what the product of powers is. So if you're multiplying two of the same numbers, the powers, the exponents are added, okay? So then if we have quotients of powers, so that's division. So what the same thing, if it's the same number, we subtract the exponents. So M and N are subtracted. So it'd be like 3 subtract 2. If this was 3 and this was 2, so it would be A to the power of 1. Okay, power of a power. If you see brackets around a power and then a power outside, we multiply them. So we times it. So if it's a 2 and a 3, it becomes 6. So A to the power 6. Now a power of a product. So the M is multiplied on the A and the B. Okay, see how it's AM and BM? In power of a quotient, the M goes on the A and the B. Okay. So you need to understand these to be able to move into the questions that we're about to do. You have to know that when it's a product of power, so if you're multiplying the same base, we add the exponents. When we're dividing the same base, we subtract the exponents. If there is a power of a power, so a bracket in between the two powers, you multiply that. If it's a product of a power here, you are going to, the M goes to each term when they're different, right? M goes out. And then a power of a quotient, the M goes to each of the bases as well, okay? So we have a lot of examples today. I'm not going to go through all of them. I hope to post a video of me going through some of the really important and hard ones for you to look at. But so today we can use the exponent laws to simplify expressions that have rational bases. We will write all simplified powers with a positive exponent. So on Monday and Tuesday, we looked at positive exponents. So with negative exponents, how do we get that? With reciprocals. If you do not know how to do that, you need to go back. You need to know how to write a negative exponent as a positive exponent. So let's look at this example. So C, right, we have the same base. We can take these two exponents, and what do? It's the same base, we add. So negative 8 plus 6. So negative 8 plus 6 is negative 2. Now, it says it has to have a positive exponent. To get rid of the negative exponent, we do the reciprocal of the base. So that means we flip C to be 1 over C to the power of 2. Okay? B, so we are dividing by the same base. When we're dividing the quotient, we subtract. So 3 subtract 7 equals negative 4. Now, to change the negative exponent, like you should remember, is flip the base. So 1 over B to the power of 4. Okay? Here, when we're multiplying the exponents, we multiply a power of a power. So negative 2 times negative 5 is 10. Okay? All right, so here we're going to simplify. So I'm going to go through a few of these. So with this 5 on the outside, this is when the power has to go to the A and the B. So it becomes A to the power of 5 and B to the power of 20 because you're multiplying the 4 by the 5. Okay, let's look at B. Same thing. We need to take that -4 and multiply it by these powers. So it's going to be, well, first, actually, our first step, you should have noticed this is a negative exponent. So the first step, change it to a positive exponent, always. Flip these, make it reciprocal. So d to the power of 5 is the numerator, right? All right, so then we do 5 times 4, so 20, and 2 times 4 is 8, and that's our answer. Okay, over here, in the green is shown by not doing the positive exponent first, okay, by actually doing -4 to the power and times it by 2 and then flipping it, okay? That's what the green shows. Now see, lots of arrows here, but the 3, like I said, is applied to each of the terms. So the 3, it's 2 cubed, so you have to do that, and then you have to do x to the power of 2 times 3, so it's 2 times 3 is 6, so 8x to the power of 6. Now this 3 has to go with this 3 right here. So we take 3 to the power of 3 is 27, and y times to the power of 3 is y to the power of 3. Okay, this one has negative exponents. This one's interesting. So your first step could be one or two ways, okay? So you can get rid of this negative exponent first, right? So that's what I said I would normally do, is I would flip this base. So I'd put 1 over 4xy to the power of -6. That's what I would do. And then my next step would be to get this power in. So 1 to the power of 2 is 1. 4 to the power of 2, 16. X to the power of 2, x squared. Y to the -6 times 2, -6 times 2 is -12. Now this -12 cannot stay there. That's a negative. So we have to flip this. We have to do the reciprocal. So this has to move on top. So it becomes y to the power of 12 on top over 16x squared. Okay, a little confusing. Over here, we didn't do a positive exponent at the first. Okay, so you did 4 to the power of -2, so 4 to the power of -2, x to the power of -2, y to the power of 12. See that? And then we had to flip these, right? Because these have negative exponents, so they go on the bottom, and then we just did it out, okay? All right, these look like some ones that I'm going to do in another video. If you want to know how to do this, it's the exact same process, but I'll go over it in a separate video of me walking through how to get the answers, okay? Same as these, lots of examples for you to look at to understand. So Wednesday, so today, you need to go onto the worksheet that's called Exponent Rules and Practice. You need to do these questions today, okay? And then Thursday, this is what we'll do, okay? So Wednesday, this is what we're working on. You're doing 10 to 18, 24 to 28, 31 to 36. If you have free time and you want to do some more questions, fill your boots. That would be great. Okay, so like I said, I'm going to post another video of me going through some of those hard examples, okay? Like I said, if you don't understand how to do the previous stuff, you need to go back and understand. This is very, very complicated if you don't understand the basis of what we're doing here. So please go back and refresh your memory. If you have questions, join the Google Meet. I will go over some of the problems that you have to do, and I can walk you through a few of them, or email me and I can try to help you as best I can, okay? Good luck.